Every day we produce tons of waste. Unfortunately, the overwhelming majority of what we throw away ends up in landfill. There are about 400 landfills in operation in the Czech Republic, and others that have already been sealed. We have stored a huge amount of difficult and dangerous material underground. This legacy is often rightly referred to as an ecological time bomb for the next generation. Various rotting and fermenting processes take place in the solid municipal waste stored in a landfill. Viruses, bacteria, and other harmful substances multiply. In order to prevent these dangerous substances from entering the soil and endangering the ecosystem, the landfills are insulated with sealants. However, these crack over time, causing leakage into the soil. Finding a place for the landfill is also very difficult, as it can devalue a lot of agricultural land. In a modern incinerator, we get rid of the waste on the one hand and use its energy potential to produce heat and electricity on the other. How? Find out in the next few minutes as we present the workings of the Liberec Municipal Waste Incinerator made by Termizo plc. The incineration plant is a waste-to-energy facility. Specifically, it uses solid municipal waste as a fuel for the thermal process. This waste would otherwise end up in landfills. The termizo plant has an annual capacity of up to 117,000 tons, which is about half of the waste produced in the Liberec region. This capacity is therefore filled without difficulty. The annual heat supply to the central distribution network amounts to 630,000 gigajoules, and the plant produces 26,000 megawatts of electricity per year. The Termizo Liberec incinerator was put into operation in 1999 and has been running without any problems ever since. 4 highly trained workers take care of the running of the plant in continuous shifts. The operation of most technological units is fully automated. The operator supervises and inspects the individual parts of the incinerator. The system by which the incinerator converts waste into electricity and heat is shown in this diagram. First, the waste is stored in the bunker, from where it goes to the boiler, where controlled combustion takes place. The steam produced is then fed to the heating plant and then to the central heat supply network for individual customers in Liberec. In the meantime, the steam is used in a turbine that drives a generator where electricity is produced. This is used for its own needs, and the surplus is supplied to the power grid. This is how the Termizo incinerator works in Liberec. Let us take a closer look at its technology. Solid communal waste is taken into the bunker. This is accessible through 5 hydraulic doors. The waste is mixed in the bunker using a crane and is constantly being prepared for perfect combustion. If necessary, large volume waste is crushed using hydraulic shears. After preparation, the crane loads the waste into the funnel of the furnace. As has already been said, the plant can process up to 117,000 tons of waste per year, which means up to 15 tons of waste per hour can pass through the hopper. From the hopper, the waste passes into the hydraulic feeder, which then sends it to the grate. The waste is burnt on this sliding grate. Combustion air is fed to the fire. This is blown under the grate by a fan and heated by a steam heater. This causes a slight vacuum in the bunker, which reduces the emission of odour and dust to the immediate vicinity. Natural gas is used to ignite the waste, and the subsequent combustion process is fully automatic. The control system monitors individual combustion parameters and continuously evaluates any deviations from the required state. This ensures perfect combustion and the high quality of non-combustible residual slag and ash. Burned slag contains up to just 1.5% carbon, which is proof of the high quality of the combustion. The combustion temperature on the grate varies from 900 to 1100 degrees C. This steam is first fed to the back pressure turbine rated at 3.5 megawatts. Thanks to the reduction of the turbine, steam parameters are reduced to 230 degrees C and 7.5 bar. Up to 16,000 megawatt hours of electricity are supplied annually to the power distribution grid. The steam is then taken from the turbine to the central heat supply system in Liberec. The heat supply used is roughly 630,000 gigajoules per year. The described process of the combined production of heat and power is called cogeneration. The use of the steam generated has an efficiency of around 80%, which demonstrates how energy efficient the process is. If the customer does not consume all the heat produced, then the heat is used in a condensing turbine with a rated output of 1 megawatt. Some of the electricity generated is used for our own needs, that is, to ensure the operation of the incinerator. The rest is delivered to the power grid. In addition to high energy efficiency, the Liberec incinerator also places great emphasis on ecology. The resulting flue gas is cleaned along with the water used and fly ash. This is why, in general, heat and electricity produced in incinerators are some of the cleanest energies. Now let us take a look at the flue gas cleaning process. Very strict emission limits are imposed on waste incineration. To achieve these emission limits, 4 stages of flue gas cleaning are installed in the incinerator. These are the reduction of nitrogen oxide, fly ash, dioxin decomposition, and wet scrubbing. Reduction of nitrogen oxide in the flue gases takes place directly in the combustion chamber, which is fed a solution of 25% ammonia water. Next, the selective non-catalytic reduction of nitrogen oxide takes place. The fly ash contained in the flue gas is trapped by an electrofilter. The residual fly ash is then caught by a catalytic textile filter, the main function of which is the decomposition of dioxins. Dioxins are disposed of using a special filter. On this dioxin filter, they are decomposed by catalytic oxidization into elemental components, namely water, carbon dioxide, and hydrogen chloride. The residual gaseous oxides are purified from the flue gas using a wet process. There is a flue gas scrubber which works in 3 stages. The first stage is the quench. This cools the hot flue gas to approximately 65 degrees C through the injection of wash water. Smoke gases are saturated with water that absorbs most of the gaseous acids such as hydrogen chloride and hydrogen fluoride. The quench also condenses gaseous metal oxides such as mercury. Meanwhile, deeper gaseous impurities get into the service water. In the second stage of the flue gas scrubber, sulfur dioxide and sulfur trioxide are absorbed. There is contact between the flue gas and the softened water, to which sodium hydroxide is regulated. The flue gases flow upward from the bottom, thereby filling the scrubber against the current of the wash water system. This results in the exchange of substances and the removal of sulfur oxides from the flue gas while maintaining a pH value of 6 in the wash water. The third stage of the flue gas scrubber is the ring jet. This ensures the separation of dust and aerosols, the smallest particles. After the third stage of wet cleaning, the flue gases leave the stack. Flue gas is continuously measured at the very end of the stack. In the event of a fire extinguisher failure or a power failure, the flue gas is automatically transferred to the so-called emergency stack, which is permanently closed by automatically controlled flaps. This will safely remove the flue gases into the atmosphere even during exceptional circumstances. Besides combustion gases, fly ash and slag are also produced during the burning of waste. So that the raw ash does not indicate any hazardous properties, soluble salts and extractable heavy metals are removed from it using the acidic water coming from the flue gas scrubber, specifically from the first stage, that is, from the quench. The fly ash, which is stored in a silo after its separation from the flue gas, is fed into 3 extraction tanks. Here it is extracted in acidic water with a pH 3.5 at 65 degrees C. The subsequent drainage is carried out on a vacuum filter belt. The scrubbed ash goes to the slag bunker where it is mixed with the slag, which likewise shows no dangerous properties. The resulting material is used as a building material for landfill construction. The features of this product are guaranteed for production according to their quality certificate. In order for the incineration plant to be truly ecological, the water used both for the wet cleaning of flue gases in the scrubber and for the leaching of fly ash must also be cleaned. This acidic water flows into a treatment plant made up of 3 tanks. Chemicals such as lime, hydrochloric acid and others are gradually added to the water. At pH 9.5, heavy metals are eliminated. These sediment into a fine sludge in the form of flakes. This sludge then settles in a sedimentation tank from where the now clear water flows for final inspection. The sedimentation tank slurry is rinsed and drained in a candle filter until a solid waste forms. This is called filter cake. It is collected in special containers and taken away for solidification, after which it is deposited in hazardous waste landfill. In addition to the production of the building material from slag and fly ash, known as spruck, a large amount of iron also leaves the incinerator. This is separated from the slag. Thanks to the iron separation device, up to 75% of metals is found in the slag each year. Another environmental benefit is the fact that the energy recovery of waste saves on primary raw materials. The production of heat in an incineration plant will limit production from other sources of energy, and in the particular case of Liberets, this means saving natural gas. This is beneficial not only for the environment but also for citizens. Operating the Liberets incinerator is a complicated business, and we hope that we have managed to explain the system of its operation as clearly as possible. We do not have to destroy the environment in which we live. Let us try to use seemingly useless waste to our advantage. Our children will certainly appreciate it in the future.